Welcome to Mac 2311 for Engineers, Exam 2, problem number 12. In this problem, they go ahead and they tell you that f and g are continuous functions. They give you the derivative of f and the derivative of g, and then they want to know which of them have a vertical tangent line at 0. Okay, so, and obviously your choices are f, g, neither, or both. So, okay, a vertical tangent line, we know if we looked at the graph, it would look something like this or something like that, where just for one tiny moment it becomes straight up vertical, essentially that your derivative is going to infinity. So, but you can see that before that occurs and after that occurs, in both of these situations, your derivative is still the same sign value. It was increasing, and then it's still increasing. Here it was decreasing, and it's still decreasing. So what we can do is, if we're wondering, we're assuming this to be continuous, but wondering, do these guys have a vertical tangent line at 0? Well, we can take the limit from both sides, the left-hand side and the right-hand side, of 0 for these guys here, and make sure that they match up in sign value. So, for example, the ln of x. If we took the limit as x goes to 0 from the positive side, and the limit as x goes to 0 from the negative side of ln of x, absolute value of x, what's happening is, no matter which way you come from, you're going to absolute value it first, so it's going to be always a small positive number. And then if we remember the graph of the ln function, looks like that. Well, the graph of this guy, if you're a small positive number, you're going to be down here at negative infinity. So now that means that when you come in from the right-hand side, you're at negative infinity, and when you come in from the left-hand side, you're at negative infinity. So what's going to happen is you're actually the same, so it would look something like this. You would be decreasing and keep on decreasing. You'd go and get really, really big, going to negative infinity is your derivative, and then coming from the other side of this, you would be coming from negative infinity and still be decreasing. So this guy should have a vertical tangent line at 0. Now if we go ahead and check this one, you'll see that it actually behaves slightly differently. We keep the limits, but now we're going to go ahead and switch this up to that function there. And then what we can see is when you go to positive, you go to 0 from the positive side, from the right side, what's happening is you're going to get a negative on top, a positive on bottom, so it's overall going to be negative, and you're going to get basically negative 2 divided by 0, which you know goes to infinity. So this is going to just be negative infinity. Here, it's pretty much going to be the same thing. You'll end up being divided by 0, so you know you're going to go to infinity. But then when you plug in a small negative number, you'll get a negative on the bottom and a negative on top. The double negative makes it a positive. So it's overall just going to be positive infinity. So here you can go ahead and see that it's not going to go ahead and behave like this. If we think about what this means, that if you're at 0, wherever your function happens to lie, the slope coming in from the right-hand side is going down to negative infinity, and the slope coming in is going up to positive infinity. So, I mean, it's getting really big and then really small. So if you were to graph this picture here, it would look something kind of like a cusp, right? You're getting really big, and then you're getting really big from the negative direction. So it would go up like that. A really positive steep slope, and then it could switch over and be a real negative steep slope. So this guy here wouldn't have a vertical tangent line. Meanwhile, the first function would have a vertical tangent line. And that is your final answer.